Okay, so for the next part, we're going to look at monitoring aquifer depletion. So there's two ways that we can do this. The first is we can go along to our boreholes and we can measure the water level that we find within it. And the water level within the borehole will reflect the height of the water table. So it will be that high in this case. And we can measure either how deep it is from the surface level or how high above sea level it is. So height above sea level being like an agreed 0, or depth below surface. And the depth, the height above sea level is quite a standard one to see, which might be a bit confusing if you don't come across it before. So we can check boreholes for the depth of the water table. But this can be quite slow or difficult over large areas. So for large areas and constant monitoring and frequent returns to the same area, we turn ourselves back to satellites. So satellites obviously orbit the Earth frequently if they're in low Earth orbit. So these can get us like survey the entire Earth in 30 days. And they typically use gravity. So the changes in the density or mass of water in aquifer affect the gravity experienced above them. And this means that if we have our GRACE satellites, so G, which is the gravity recovery and climate experiment, which we've come across before when we were looking at ice, we can use those same satellites to measure aquifers. So this is the GRACE satellites, and these are two satellites in train, and they measure the different distance between them using a laser, and as they travel over the Earth's surface, they either increase their distance or decrease the distance between them based off of the force of gravity. So the more water in an aquifer equals more gravity, and the satellites will move closer to each other. Aquifers with less water in them will have less gravity because they've got a lower mass, and so they will be further away from each other over that point. So that's how we can measure large areas very quickly and accurately. So some examples of aquifers that are overexploited. You have the high plains aquifer. And this is in the USA. And it's made up actually of a number of different aquifers, but it's really important for agriculture, and it's largely fossil water, so paleo water, which is not being recharged, which is a major problem for sustainability. given how important it is for a growing population and agriculture. Another example then is the North China Plain. Which is a really productive agricultural region of China, but there's not so many rivers, so a lot of groundwater is used for irrigation. There's also a growing population, and they have had to introduce a number of mitigation techniques, things like low pressure irrigation and consumer use changes and afforestation, and cross basin transfers as well. And the last one then is Malta, which is a small island in the Mediterranean, which has low rainfall, high evapotranspiration, and so a lot of the aquifers are contaminated with saltwater intrusions through overexploitation. And also things like sewage and nutrients, which are another major issue for aquifers. So sewage and nutrients can cause things like blue baby syndrome, and you have water that is high in nitrates, typically from agriculture. And so let's have a look at artificial recharge. So if we have an aquifer that we rely on, and we've got our recharge zone, and it might be quite seasonal. So we get a lot of rain in our recharge zone, but we get so much rain that a lot of it ends up flowing off into rivers because it exceeds the infiltration rate. So we get surface runoff into rivers, and we don't really recharge our aquifer so well. Which is an issue because in the drier seasons, we're going to be extracting this quite a lot to irrigate our crops or use domestically. So what we might want to do in our winter period is to perhaps capture some of this surface water runoff to increase the amount of infiltration. So we might build a lagoon that captures this surface water runoff, and this will slowly percolate down into our aquifer and increase the amount that is infiltrating. And therefore recharge our aquifer. Alternatively, what we might do is take that water that we've captured and actually pump it into the aquifer. So we can pump recharge the aquifer. And this means that we will have a better way of controlling the level of water in our aquifer, and we can use the aquifer as a store for seasonal demand. So there is a large managed aquifer that supplies London with water for summer peak demand, as an example.